Hello students, welcome to this new video on problems related to basic concepts of radiation. Now very quickly get into one problem we will take and see how we can solve a problem related to radiation. Now please read the problem along with me. Calculate the following for an industrial furnace in the form of black body and emitting radiation at 2500 degrees centigrade. So if to consider industrial furnace as a black body and which is emitting a radiation at 2500 degrees centigrade. So what are the things that we are supposed to find it out? First one, monochromatic emissive power at 1.2 micrometer wavelength. So this is second one, wavelength at which the emission is maximum. Okay, next is maximum emissive power, total emissive power, then total emissive power of the furnace if it is assumed as a real surface with emissivity equal to 0.9. So if it is not a black surface, if it is some other surface, then the emissivity is given as 0.9. How to do it? Now let us start. I have just solved the first one. Given temperature is 2500, always be aware that you need to convert it into Kelvin whenever you are solving radiation problem. So it is turning out to be 2773 Kelvin. Lambda is 1.2 micrometer and epsilon is 0.9, that is emissivity. Now the first thing, monochromatic emissive power at 1.2 micrometer. So we know if we want to find out monochromatic with respect to a certain wavelength, emissive power, which is the law, that law which we need to know is Planck's law. So what does Planck's law say? Planck's law say that the emissive power, monochromatic hemispherical emissive power of a black body is given as C1 lambda to the power of minus 5 divided by exponential to the power of C2 divided by lambda t minus 1. So what is C1 and C2? The C1 is, you can see, it is 0.3742 into 10 to the power of minus 15 watt meter to the power of 4 divided by meter square. C2 is 1.4388 into 10 to the power of minus 2 meter Kelvin. And lambda, for what lambda we need to calculate monochromatic emissive power, that is 1.2 micrometer, that is 1.2 into 10 to the power of minus 6 meter, and temperature is 2773 Kelvin. Now please substitute all these values here. I have an answer which is already calculated. So E lambda B, that is monochromatic emissive power of a black body, is equal to 2.014 into 10 to the power of 12 watt per meter square. Now next thing, what is the second thing that we are supposed to find it out? The second thing we have to find it out is what? Wavelength at which the emission is maximum. Correct? Wavelength at which the emission is maximum. Which law we need to consider? So that you need to know. You need to be aware of that. So the law which we need to consider is Wien's law. So this is the second one which we are seeing. So lambda max into T is 2898. So which is that? Please calculate. Lambda max is 2898 divided by 2773. So what is that answer you are going to get for that? So the answer is equal to 1.045 micrometer. So which is 1.045 micrometer. So the second thing is also done. So the maximum value at which C lambda is. So now we need to find it out for this particular lambda max, that is 1.045 micrometer. What is the emissive power? So that is our third one. That is maximum emissive power. Maximum emissive power, that is E lambda of B is equal to what? Again we need to use that. Again we need to use that. So maximum emissive power, that is you can use that lambda B max is equal to, again use that same formula, that is what is that? C1 lambda to the power of minus 5 divided by exp of C2 divided by lambda t minus 1 So please substitute all the values that like we have done. So this is lambda max that you need to consider. So if you try to consider the lambda max, so what is the answer that you are going to get? So if you try to substitute everything here, okay, okay. So you're going to end up with so students, see here, how do we calculate maximum emissive power at lambda max? So this is lambda max here. So if you try to simplify this during derivation itself, you can simplify this and keep it as, so lambda max is equal to what, 2898 divided by t, correct? So if you try to put that here, so the simplified equation for finding out maximum emissive power is equal to, you're going to end up with this equation. So that is 1.285 into 10 to the power of minus 5 t to the power of 5. So this you can remember, or you can directly put it here and get the answer. So this is I have just given it. So lambda b max is equal to so just do it. So what is the value that you are going to get? For that, it is equal to, so substitute please, that is 1.285 into 10 to the power of minus 5 into 2773 to the power of 5. So E lambda B max is equal to, E lambda B max is equal to 2.1 into 10 to the power of 12 watt per meter square per meter length. So per meter length. So this is the answer for that. Okay, so this is done. So what is the next one? That is the fourth one, total emissive power. Total emissive power for the black body, again EB. So what is that given? The total emissive power is given as, using Stephen Boltzmann law, sigma t to the power of 4, which is what, 5.67 into 10 to the power of minus 8 into 2773 to the power of 4. So EB is equal to how much? Will be equal to 3.352 into 10 to the power of 6 watt per meter square. So considering that epsilon equal to 1, that is considering the body is black. Okay, next, what is that fifth one? So the fifth one will be total emissive power E with emissivity. So again, condition given that total emissive power E with emissivity epsilon equal to 0.9. So what is that? So EB will be equal to, so it is not, no longer it will be EB, it is just E is equal to what? Epsilon sigma t to the power of 4, which will be 0.9 into 5.67 into 10 to the power of minus 8 into 2773 to the power of 4. So E will be equal to 3.017 into 10 to the power of 6 watt per. So this is one problem where you can find it out. Now here I want to mention something. Now suppose say there is a body, say having certain temperature T1, and this is surrounded by some body. Okay, now that means our atmosphere is with some temperature T. So how do you find out the total emissive power? It is just sigma T1 to the power of 4 minus T2 to the power of 4. Sorry. So please understand that it's a difference in temperature. Okay, for a black body. For black body, epsilon equal to 1. So such kind of problems and many more problems are there in the textbook. Please practice. Okay, thank you.